Okay, so this is the probability of simple events homework page. So when we talk about probability, it's written as a fraction, and on the bottom is usually where we put our total. So sometimes if it's a percent, if they talk about percentages, then we know the total out of a percent would be 100, because that's the maximum, that's 100%, that's total, that equals 1. But it could also be, like on example 1, it could be 4 if there are 4 places on a spinner. So it just depends on the circumstance that they give you. So like example 1 says there are 4 equally likely outcomes on this spinner. So automatically 4 needs to go on the bottom, because whatever they ask you, it's out of 4 different options. Determine the probability of spinning green or blue. Okay, so we have one green, what would you call that, spot on the spinner? I don't know. One green and one blue. So together that would be 2. So the probability of landing on green or blue would be 2. And there are total of 4 spots. So you could land on any of them. That's why 4 is your total. So we would reduce that 2 out of 4, and that would give us 1/2, or 0.5, or 50%. When it talks about complementary events, 2 events in which either one must happen but cannot happen at the same time, the sum of the probabilities of complementary events is 1. So this is a lot of the 100%. You see this a lot with percentages. Like example 2, there is a 25% chance that Sam will win a prize. So 25% chance. If we talk about percentages, the maximum percentage we can have would be 100. So if there's a 25% chance that Sam will win a prize, what's the probability that Sam will not win a prize? So we would just take the total of what it could be, which would be a 100%, and subtract the chance that she might win. So 100 minus 25 would be 75. So that would be written as 0.75, because you do your 1, 2 as a decimal. 75%, 0.75, or 3/4 as a fraction. So question 1, there's a 90% chance it will rain. What is the probability that it will not rain? So 90% chance that it will, what's the remaining percentage to get to 100? 100% minus 90%. The only percentages that is left is 10%. Number 2, 1 pin is chosen without looking from a bag that has 3 blue pins, 6 red, and 3 green. Determine the probability of the event below. Express each as a fraction, decimal, and a percent. The probability of a green. So first of all, we need to know the total. So I'm going to count all of these numbers up. I've got 3 plus 6 plus 3. So that would be 12. So that's what goes on the bottom. And then I need to look and see how many green I had. It says there were 3. So 3 out of 12, but that's not an answer choice because I haven't reduced my fraction. So I'm going to reduce my fraction. I need a number that can go into both 3 and 12. 3 will go into both, so I'll divide 3 by 3, and that gives me 1. And divide 12 by 3, and that gives me 4. Okay, so and the only answer choice that has 1/4 is B. Okay, question 3 is the same, very similar. 1 pen is chosen without looking from a bag that has 3 blue, 6 red, and 3 green. Determine the probability of the event below, blue or red. So again, I need to count how many I have total, so add all of these up. 3 plus 6 plus 3 is 12. And so blue or red, so that means I'm going to add how many blue I have and how many red I have. So that would be 3 plus 6. That would be 9. And then we need to reduce it from there. Think about what numbers can go into both of these. Another similar question. One pen is chosen without looking. That has 3 blue, 6 red, 3 green. Determine the probability of it not being red. Okay, so again, we add all these up. The total is 12. Not red. So I have 3 blue, 6 red, so that's not going to be included, and then 3 green. So add those two numbers that are not red. Well, that was the wrong color choice. Question 5. A set of 30 event tickets are placed in a bag. There are 6 baseball tickets, 4 hockey tickets, 4 basketball, 2 football, 3 symphony, 2 opera, 4 ballet, and 5 theater tickets. 1 ticket is selected without looking. Determine the probability below. Determine the probability that you draw a basketball ticket. So it told us the total, 30. And then it says the probability of pulling out a basketball ticket. So let's find where basketball tickets were. There's 4. And then we need to reduce that. So I know for sure I can reduce it by 2. So that would be 2/15. 2/15. Okay, we're gonna say it's C on that one. Question 6. A set of 30 event tickets are placed in a bag. So this is the same. 1 ticket is selected. Determine the probability. So the probability of landing on a sports event. So if we go through and look at all the ones that are sports, we've got 6 baseball, 4 hockey, 4 basketball, 2 football. Okay, and that's all the sports that I'm seeing. Everything else is like theater. So we can say 6 plus 4 plus 4 plus 2 is 16. So 16 out of 30. I'm going to reduce it. I'm not really sure what happened on question 5 because when I reduced it, that answer choice wasn't exactly there. 16 out of 30. If we reduce, let's say we reduce it by just 2 for now. 16 divided by 2 is 8. 30 divided by 2 is 15. Oh, thank the Lord. That's an answer choice. Number 7, the same thing. 30, but in this case, what's the probability of landing on opera or ballet? So you'd have to come back and find how many opera, which is 2, how many ballet, which was 4. So 4, 5, 6. All the answer choices are in percentages. So you would need to set up some type of proportion to figure out what that percentage would be. The same question, out of 30, what's the probability of landing on soccer? They had how many soccer tickets? I don't think they had any. 6 baseball, 4 hockey, 4 basketball, 2 football, 3 symphony, 2 opera, and 4 ballet, 5 theater. There is no. So it's not that there's not enough information, it's that there is 0% probability. Again, your total is 30 out of 30 tickets that you land on something that's not symphony. So how many symphony were there? There were 3. So basically everything else. So you can either add up the remaining numbers, or you already know what your total is. Take your total and subtract the 3. Question 10 is the same. Out of 30, how many picked theater, or what's the probability of pulling a theater ticket out? Be 5. And then reduce that 5/30. A spinner. The spinner shown is spun once. Determine the probability of each event. How likely is the event below? So first of all, we need to see how many options, how many places the spinner could land. So the spinner could land on 1, 2, 3, 4, 5, 6, 7, 8 different places. So that's my total is 8. And the probability of landing on an even number. Okay, so the total is 8, and then the probability of an even number. So how many even numbers are there? There's 1, so we got 2, 4, 6, 8. So altogether that would be 1, 2, 3, 4. So 4 out of 8 are even numbers, and if we reduce that, which we have to, would be 1/2. So it can't be this one, can't be this one. Either 50% or 25%. Think about what 1/2 would be as a decimal. If you need to do that, you can do that. Same thing on the number 12. We've got 1, 2, 3, 4, 5, 6, 7, 8. The probability of rolling a prime number. Prime numbers are those numbers that can only be divided by 1 and itself. So I'm going to tell you that those prime numbers are 1, 3. Okay, just kidding. So we're starting with the number 2, not 1. And that would be then 5 and then 7. So the prime numbers we have are 1, 2, 3, 4. So there's 4 prime numbers. Okay, so again, out of 8, factor of 12. So that means that it can divide, that 12 can be divided by that number. So 12 can be divided by 2, 3, 4, and 6. So that would be 4 numbers.
That don't make no sense.
And 1. So sorry, forgot about that one there. So that would be 5 out of, should be 5 out of 8. Number 14, a composite number, probability of it being a composite number. It's a positive integer that can be formed by multiplying 2 smaller positive integers, not including 1.